Hello, Geometry Land. We are starting our next lesson, which is 11.1, circumference and arc length. So circumference I know we've all seen before. Just a reminder, circumference is the distance around the circle, right? It's the distance around the circle. So the formula for that would be C equals 2 pi r, or we use C equals pi d, which is the diameter, right? So it's either twice the radius times pi, or it's the diameter times pi. For Pi Day, I like to do lots of fun stuff, and this year, Pi Day was cut a little short because of the pandemic. But that being said, I do have one important note. I want you to know that you should always use the pi key on your calculator, all right? 3.14 is a good approximation of pi, but the pi key is much more accurate. So use the pi key to do your calculations and then round to the hundredths place. On my calculator in particular, if I type in something like 2 pi, and hopefully you can see that okay, it will spit out 2 pi. So sometimes you have to do 2 with a decimal and then times pi, and that way it will actually calculate it out for you. So that's 6.28 if I round to the hundredths. So just so you're aware, sometimes questions will ask you to give the answer in pi, and sometimes they will want you to round. So let's do an example together. Circumference of a circle with radius 9 centimeters. We know our r is 9. We want to find the circumference, so I'm going to write down my setup, and then I'm going to plug in what I know, which in this case is 9 for my radius. Well, 2 times 9 is 18, so the circumference is 18 pi. I can approximate that to 56.55. In this case, we were working with centimeters. So take a second. Actually, let's do number B together. That's right, number B, I said it. So we've got our circumference again, which is 2 pi r. We're trying to find the radius this time, and we know the circumference is 26. So I have 26 equals 2 pi r. Then you divide by 2 pi on both sides. So we have 13 over pi is equal to r, which is approximately 4.14, in this case, meters. So that's circumference. Hopefully we're all feeling pretty comfortable with it. Arc length. Arc length is the next one. This is new and a little different. So an arc length is a portion of the circumference of the circle. So you can use the measure of the arc in degrees to find its length. So this is why we spent those couple days talking about circles and radii and chords, and also calculating minor and major arcs, because we're going to use them to find arc lengths. So we have right here, we want to find the arc length of AB. And I'm going to color code it in yellow so I can see kind of what I'm talking about. It's this guy right here. That is the arc AB, right? So we know that arc length is going to equal the measure of arc AB in this case, divided by 360. We've got our little equation guy right here. And then times 2 pi r. So I'm going to plug in what I know. I want to find the arc length. AB, I can measure that arc. I know the central angle, it's 60, so the measure of arc AB is 60. So I have 60 over 360 degrees times 2 pi, and my radius is 8. So when I plug that into my calculator, I get an arc length, which I'm just going to abbreviate as AL, is equal to, because I'm just plugging that all in and seeing what I get, 8.38. And in this case, it should be centimeters. So let's take a look at our next one right here. We are trying to find the measure of arc RS. Now be careful. RS is this right here. It's this right here. So we know our arc length is equal to the measure of RS over 360 times 2 pi r. I'm going to plug in what I know. I actually know the arc length this time. It's 44. That's the arc length. So 44 equals, we're trying to find the measure of RS. divided by 360 times 2 pi, and I know my r as well. My r is the 15.28. Sorry, I went off the page a little bit there. So I need to divide my 44 by 2 pi 15.28. That's going to equal arc length time divided by 360. And then I'm going to multiply both sides by 360 so that I don't have to deal with that anymore. So my arc RS is equal to this whole funness right here, which when I plug into my calculator is 165 degrees. So I can find the measure of the arc given the arc length, and I can measure the arc length given the measure of the arc. All right, the last thing we're going to talk about today, and then I'm going to give you guys some time to practice, is radians versus degrees. I know that there has been a lot of confusion around radians and degrees. Remember, one of these is like using dollars in America, and the other one is like using pounds in England or euros in Europe. They're the same. They both have to do with the angles of circles, right? Just like dollars and pounds and euros are all money. So these have to do with the measure of angles. It's just that radians measure an angle as it is proportional to the radius of a circle, right? To the radius of a circle. If a circle has a radius of 1 foot, 1 inch, 1 centimeter, any of that, then the circumference is just 2 pi, right? If we think back to our circumference of a circle equation, 2 times pi times an r of 1 is just 2 pi. So radians measure an angle proportional to the radius, hence the name. Degrees measure a circle or an angle proportional to 360. So it's just different ways that they're out of, right? That's all it is. So our conversion factor is either pi radians to 180 degrees, or you could also say 2 pi radians to 360 degrees. I know that conversions can be really tricky, so I wanted to show you a way to convert that will work no matter when or where or what you're trying to convert. What you want to do is you always want to start with what you know, and you put it over 1, if it's not already a fraction. And then you want to multiply by what you have, so it might be meters, it might be centimeters, in the denominator with what you want in terms of units in the top. All right, and that will get you out what you want. So we're going to do that with this one right here. We want to convert 45 degrees to radians. So we know 45 degrees. I'm going to put it over 1. I need to multiply by what we want, which is radians. And what we have is degrees. Well, now I can look down here and say, well, what am I going to do? Radians, I know I need to have a pi by it, because it's pi radians. And then for the degrees, I'm going to use the 180 degrees. So when I do this, 45 times pi divided by 180. So 45 pi divided by 180. I can reduce that down, and I get pi force radians. All right. This will always work as a way to convert from what you know to what you want. You can use it with the metric system. You can use it with dollars, any of that. So our next one, we are converting 3 pi halves. It's already a fraction, so I don't need to write it over 1. We want it in degrees. So I'm going to put degrees right here. And we have radians. So radians goes in our denominator. Degrees, I'm going to use this one this time. So for degrees, I'll put 360 in here. And for my radians, I'm going to use 2 pi. Now this will reduce down to our pi and 180, right? So it doesn't matter which one you use. I just want to show you you can use either way, and it works just fine. So we now have 3 pi times 360 over 2 times 2 pi. Our pi's are going to cancel out, right? So we have 3 times 360 divided by 2 times 2, which is 4. So when I reduce that down, I'm going to end up with 270 degrees. So that's how you convert between the two. Remember on Desmos, you need to click the little wrench in the upper corner, and there's bars towards the bottom of that setup screen. One of them says radians and the other one says degrees. So just to remind you, your calculator likes to be in radians, so you have to double check when you're using degrees to make sure it actually is, correct and working right. All right, I want you to practice. Take a minute, pause the video, practice for the next 6 problems. All right, practice for the next 6 problems, and we'll go over the answer. All right, you should have practiced. For number 1, we know that the diameter is 5. That means that the radius would be 5 halves. You could plug in a diameter of 5 if you wanted to. It doesn't matter, right? So you should have gotten 15.7. 15.7, or 5 pi if you left it in pi. For number 2, you should have gotten 2.71 for the radius. 2.71 for the radius. For number 3, it should have been 240 degrees. Ooh, that looks like an 8, doesn't it? Sorry about that. There we go, 240 degrees. For number 4, you know the arc length is 10.5, so you plug it in. You know the central angle is 150, so you solve for r. So you should have gotten 4.01 for the radius, 4.01. For number 5, you know the diameter. Be careful here. This is the diameter is 9, so the radius is 4.5. So you plug in 4.5 for your radius, and you should get an arc length of 5.89. An arc length of 5.89, because we were trying to find this guy, QP. We're trying to find this guy. For this one, for the track, you want this inner line right here. It's harder to see, I know, but you want the inner line right here. So we don't need to use this 42.02 because that's to the outer part of the track. You see how it goes all the way? So we can just ignore that, which means we want this 36.8. We've got a semicircle here and a semicircle here. So that means I've got 2 semicircles, which is the same as a full circle, right? And then we've got 2 straightaways, and the straightaways are both 84.39. So I plugged that in. You should have gotten 400 meters. 400 meters. Please email me if you have questions on any of this. Skills Practice is posted.